Okay, this is Mr. Weideman, and I'm here to help you with your UT Quest assignment on free fall. A lot of problems in this particular assignment involve stuff being dropped. And it doesn't matter whether it's dropped, what the object is, or how high it's dropped from, or even if it's even dropped on this planet. The approach is always going to be the same. One thing that we're always going to know, since it's in free fall, is we're going to know its acceleration is going to be g. Negative 9.81, or if the problem gives you negative 9.8, you want to use that. And it does make a difference, and it also makes a difference. It is negative. Okay, and then if you're on some weird planet, then they probably give you the acceleration constant there. No matter. Okay, we approach these problems all the same way. The first thing that we need to do is establish a reference point. Motion is always relative. And in physics, we always start our reference point is where did the problem start? Where's the beginning of the motion? And here it's my drop point. So if something is dropping, it's dropping down from me, more than likely. So therefore, in reference to my reference point, where it ends up on the ground after the drop, it's a negative displacement. And I need that. I need that to be negative. Often these problems ask us to find velocity, or it asks us to find time. And I'm going to show you two approaches. Okay, one of my favorite things to do when I don't have time is I like to go to this equation right here. Number 5, that's my go-to equation. All right, in this case here, this is a very versatile equation. You do have to be a little bit careful in what you plug in for V initial. All right, and it doesn't matter if I'm given a V initial. It's positive or negative or 0. I can appropriately substitute it into this equation, and I'm good to go. Notice how I make the gravitational acceleration constant negative. All right, and then I can solve for V final quite easily, and I'm done. All right, and an alternative method to this is I find time first, which is always a good strategy in kinematics problems. Okay, I use this equation. This is another one of my favorite go-to equations. Again, most of your problems, V initial is 0. And so this becomes relatively easy to solve for time. Notice that the displacement is negative, because relative to the starting position, it is negative. And I solve for time. If V initial is not 0, I still go to this equation, except I have a quadratic to solve. Now that I have time, I can use that in this kinematics equation, substitute, and solve for V final. Again, be very careful on your velocities. Are they positive or are they negative? And G, acceleration due to gravity, will always be negative. Pay attention to this sign convention and everything will turn out fine. Also be careful. Sometimes the problem asks you for the magnitude of the velocity. It doesn't care about plus or minus. It just needs to know the size. Sometimes the problems ask for a vector quantity. Sometimes they ask for a scalar quantity. So just be aware of that when you're working these problems. And good luck.